All right, so continuing on with the same problem, suppose instead the doctor prescribes a loading dose of 1,000 milligrams to be taken initially, then every 8 hours the patient would take a dose of 100 milligrams. Write a recursive rule for this situation. So now, where are we starting the patient? So this would be similar to if you have an allergic reaction. Some people have severe ones, and it doesn't do us any good to give them a couple Benadryl pills, right? They actually have to go in and get a shot that's going to basically, like the chlorine pump, shock the system, and it gives a massive dose immediately, and then they could take the pill form for a day or two to get everything to calm down. So 1,000 grams goes in right away. Take your last number, multiply by 1 minus 0.1, that situation staying the same, and we are just going to now start taking the 100 milligram pill again. So how does this one look? Now remember, what was the last answer? 462 or 521? 521, right? We had 521 after 2 days. So again, after 2 days, you have to make 6 calculations. So what is use of 6 now? What? Exactly 1,000? Yeah? Stays at 1,000? Yeah. Okay. So what's happened here is when we metabolize at 10%, we get rid of 10%, and then we gain it back on the next pill, and the metabolism is down. So before, the patient was under, it came up to 1,000. Now we got them over 1,000, and it comes down to 1,000. So it's kind of like a magnet. It's going to draw us into 1,000. Whether you start above or start below, it's coming into 1,000. Compare the two approaches. How are they the same? How are they different? Which one should the doctor utilize? According to the information, it works best in our body if it's at 1,000 milligrams. So remember how long it took you to get the patient there in the first situation? I would say the second one is probably a little better. All right, the Bayside Community Water District has decided to add fluoride to the drinking water. Research shows that the ideal concentration of fluoride drinking water is between 1 and 2 milligrams per liter. So we want to stay between 1 and 2, that's best. If the concentration gets higher than 4, people may suffer health problems such as bone disease or damage to developing teeth. If the concentration is less than 1 milligram, it is too low to promote dental health. People who drink the water will consume 15% of the fluoride present in the water supply in 1 day. If the fluoride content begins at 3 milligrams and 0.5 milligrams is added daily, will the concentration increase or decrease? What is the long run value? Is this a desirable level? So let's just start by getting our recursive formula written. It's going to begin at 3 milligrams per liter, right? And then we're going to add 5 milligrams per day. And people who drink the water are consuming 15% of the fluoride present in the water supply in 1 day. So if somebody's sitting near you, go through the process here, find the long run value it says, determine if it's an increase or Are we increasing or decreasing the amount of fluoride there? And then are we in the right range of values? We have to end up between 1 and 2. So do that now. So what are we getting for the long run value? What did you get for the long run value?
3.3.
Yeah. 3.3. You're gonna take your what?
It was just 3.3 repeating, so.
Let's take our 0.5 and divide by 0.15. Yes. So we're adding up 0.5 of a milligram. So yes, the long run is 3.3. That's a little bit high. They want it to be between 1 and 2. Suppose the fluoride content begins at 3 milligrams and we're adding 0.1. Describe what happens. Is this the right plan? So as I'm writing it, somebody could probably start hitting enter or make a calculation. We're going to stay at the same starting value. But now we're going to add 0.1 milligrams instead of 0.5. So we're cutting that in 20%. So what do you get? What's 0.1 divided by 0.15?
0.6 repeating.
0.6 repeating. Is that going to work? There. Right? So now it's not a healthy value either. So the last question is, let's go ahead, assuming that the fluoride content will begin at 3, determine how much fluoride should be added each day to result in a long-term value of 1 and 2. So quickly, with somebody sitting near you, make those calculations. So as we look at it, what we're trying to do is find a long-run value between 1 and 2. So I know that we're going to keep it to be 0.15. And what we're going to be doing is switching this number. So if I take that number and I call it x, and I divide by 0.15, and I make it equal to 1, right? Because I have to end up between 1 and 2. What number divided by 0.15 will be equal to 1? Multiply both sides by 0.15, what do we get? Really? 1 times 0.15? Thank you. So adding 0.1 was close, we just need to bump it up a little bit. So that would be the minimum that you could add to this problem. The maximum, you would do the same thing. What x divided by 0.15 would be equal to 2? Multiply both sides by 0.15, 0.15. 2 times 0.15 is?
0.3.
0.3. So it looks like to me if you're doing anything other than, or something smaller than 0.15 or something bigger than 0.3, it's not going to work, right? So as long as you came up with the value between those two numbers, you'd be good.